To understand how a galaxy works, astronomers rely on a very specific set of physical rules. Chief among them is the rule of spin, the observation that galaxies are highly ordered systems defined by the synchronized rotation of their stars. In a standard galaxy, the sweeping spiral arms and precise disks exist because billions of stars are moving together. They orbit a central point in a highly synchronized gravitational dance. This predictable rotation is the baseline assumption scientists use to calculate mass, chart dark matter, and make sense of cosmic mechanics. It is the physical standard for how a healthy galaxy behaves. Then there is the Small Magellanic Cloud, our neighbor located 200,000 light-years away. Instead of a neat, rotating disk, it appears as a chaotic, bloated knot of glowing gas and scattered stars. When astronomers tracked the actual movement of the stars inside this cloud, they found a severe anomaly. The stars here ignore the rule of spin entirely, traveling instead on random, disordered trajectories. For decades, scientists relied on the Small Magellanic Cloud as a standard yardstick. Because it is gas-rich and contains very few heavy elements, it was treated as a pristine model for the very first galaxies that formed in the early universe. But a pristine time capsule should not have scrambled internal mechanics. To explain why billions of stars are flying in all directions, astronomers had to look for the scars of a violent history. A research team at the University of Arizona began digging into high-precision tracking data gathered by the Hubble Space Telescope and the Gaia mission. By mapping the exact speed and direction of these rogue stars, the researchers fed the data into computer simulations and hit reverse, winding the galaxy's movements back hundreds of millions of years. The simulation tracked the Small Magellanic Cloud as it went smashing directly through the geometric center of another galaxy's disk. That target was the Large Magellanic Cloud, a massive dwarf galaxy in our local neighborhood, easily identifiable by its distinct central bar of dense stars. This direct physical impact injected a massive amount of kinetic energy into the system, breaking the internal architecture of both galaxies. As the galaxies collided, the Large Magellanic Cloud's gravity yanked the incoming stars into random trajectories. Simultaneously, its gas acted like a physical wall, stripping the smaller galaxy's spin. This impact tore out a massive bridge of shocked gas connecting the bodies, actively igniting new stars. The larger galaxy was also scarred. The impact knocked its central bar of stars out of alignment with the rest of the galactic plane. By measuring the angle of that tilt, astronomers can now calculate the amount of invisible dark matter anchoring the system. The collision transformed both celestial bodies from independent systems into permanently scarred, tangled wreckage. This wreckage isn't floating in isolation. The two Magellanic Clouds and our own Milky Way form a single, interconnected gravitational system. This 3D wireframe shows the chaotic Magellanic interaction exerting drag on the Milky Way, physically warping our stellar disk out of alignment. It also highlights the Magellanic Stream, a massive trail of ejected gas and stars currently raining down upon our galaxy. The collision hundreds of millions of years ago triggered a domino effect. The resulting debris and gravitational shockwaves are dictating the physical shape of our entire local neighborhood today. These telescope observations provide a rare view of a galaxy transforming in live action, moving beyond the idea of astronomy as a collection of static snapshots. This discovery means researchers must adjust how they use the Small Magellanic Cloud. A galaxy still reeling from a massive kinetic strike cannot be treated as a clean reference point for the early universe. Instead, the cloud serves as proof that the universe is a violently evolving system, and that catastrophic transformation is happening right on our galactic doorstep.